in order to take the CFL, or compact fluorescent light, to separate the body from the glass part, just use a tubing cutter like this and just gently go like this in this groove here, and just tighten it a little bit like this, avoiding touching the glass part. Tighten a little bit more, and you can hear it cracking as you're cutting a bit into the, go back and forth, this, maybe back off a little bit, and go a little bit in. It can become quite tight. You might want to use a cloth or a paper towel. You might want to even put a cloth over the glass part. I just don't have enough hands here to. Let's just back off here a little bit, and it's almost. So when they're separated, they go like that, and you have to cut off the wires that come off the circuit board and up to the glass part, and then you can get rid of the glass part as it has a little bit of mercury in it. Get rid of it by the usual whatever your safety disposal is in your municipality. And anyway, so here it comes like this. You have to cut the wires going down to the base too, but they come like this, and then you just take out the components. So here I've got this, I took apart this CFL, or compact fluorescent light, and these always have some useful parts in them, like 2 electrolytic capacitors, which are quite useful values. They're higher voltage, 15 microfarads at 200 volts. There we are. And some useful capacitors. Usually I end up damaging some of the other components like the coils, but quite often they'll have a useful little toroid in them. So I'm going to see how many of these parts I can get out without damaging them. It's not an easy process to get these out. The outer ones usually come out quite easily, but some of these other ones are quite tough to get out. These capacitors are coming out easy. There. This diode won't come up. Maybe I'll burn myself when I do it. I think I'm going to need a pair of pliers here. Here I'm using locking forceps that made it so I could get the diode out without hurting myself. Now, this diode here, there we are, and then that one, get that out. There's the other one here, right there. Came out okay. And let's see, first part of the first leg of the first electrolytic. Let's see if I can get that out. There we are. Now this one, there. Okay, now this capacitor there, see if I can get that out, there. And I'll try and get this transistor out, this one here. Usually you can get the transistors just by touching on one side, banging it over, and then just kind of rocking it out. That's not coming out as easy. No, try it again. Get that last bit out there. Nope. Okay, I got it out. This is more like dentistry than electronics. So, stick that one in there, see if I can get that transistor out. There. There. Okay, here we are. Start pulling on the other side. Okay. Okay, so here I'm going to try and get the other end of the capacitor out. One out. There. Okay, so here, get this out. This out. That one's gonna have to pull that one there. There. So now this transformer is going to be a little more difficult because they're usually very flimsily built, so I'm going to have to do it more gently. This one, there. Okay. Ease it out on this side. Okay, I got one side out. Now, how many do I have on the other side? I think I got 3, no, 2. 2 ends of the windings to get out on that side. Came out very easily. Oh, no. Busted the wire on the other side. But it looks like it's recoverable. This one doesn't seem to be a transformer. It's got continuity from there to there, and that one doesn't seem to have any continuity, and this one, I don't think there was one there. I think I was just seeing another lead out of another component. So this, I believe, is just a choke. So it's 2.36 millihenries. There I have it connected to the inductance meter. So 2.36 millihenries. 2 millihenries is quite useful in a lot of power circuits. So I'll put that aside. There is still some useful components on the board. There's let's see here, 2 diodes, some resistors, a very small toroid, and I think, yeah, a bunch of resistors, 2 diodes, actually 3 diodes there, and that toroid. So I'll take those out later on. First I want to check the quality of these capacitors and see if they're still good enough to be used in any project. So here I'm testing the value of this capacitor, and it's 15.25, so it's very close to what it's rated at. Okay, now I'll check the other one. $14.89, 15, very close. So the values are very close. Now I'll check the ESR on another device. So here I'm measuring the first capacitor, and it is measuring, let's see, I've got it. So it's measuring kind of high. Let's see. The ESR is flickering. Maybe it just hasn't been used in a while. Let's try the other one. DCR is normal. Let's see. But it's over 20, which is, let's see. Now there it's flickering down about 4.5. Now they're settling down. No. I better check this out directly with the meter paddles that came along with the little connectors. They're designed for measuring ESR for capacitors in a board. That's why they're so small. So let's see here. This one on here. This one on here. Oh, I guess it was the long leads. They were kind of flimsy. So the ESR is 1.5 on this one, which is excellent. And let's check this one here. This one on here and this one on here. So the ESR is about 1.75, which is very good. So note to self, don't use alligator clips. Because it adds to the resistance, and this is measuring the resistance through the capacitors. So these are designed, these connectors, these probes are designed specifically for this device. And if you they're called test tweezers. So anyway, they're designed specifically for this device. So I'll make a note to myself, don't measure with alligator clips. So once I got all these components out, the ones that I'm primarily interested in are these here, the capacitors. There's also a little choke in there which is useful, in these two capacitors. Usually when you take these apart, usually these capacitors are okay, but not always. And occasionally the transistors will be blown, one or more of these transistors. Now it comes with two power transistors. They're bipolars, and they are usually the transistor is an E13003, which is a power transistor. So anyway, I'm going to use this transistor or component tester. You can test a lot of things on this. So let's see what, hold this up here. So as you can see there, it's an NPN bipolar transistor, and it's got a low gain, 17, but it is a power transistor, and that's to be expected. Now I'll check the other transistor. So it's the other one is same gain, and it's in good condition too. So here's one of the capacitors that I'm checking. It's 1167 picofarads, and it's good. The next one I tested is okay, and it's 56.27 nanofarads. Another 57 nanofarad capacitor. Here's the last plastic capacitor I took out of there, and it's good, and it measures 3,299 picofarads. I'm curious what this tester says about those electrolytics. So it says 18.34 microfarads, measures a bit high, ESR 2.6 ohms, and let's see the other one. So I'm testing the other capacitor, and it says 18.67, and the ESR is 5.8 ohms. A little bit on the high side. The other tester gave me a lower ESR. So I'm just going to put some voltage on those capacitors for a while and see if I can bring down that ESR a bit. It might be because they haven't been used for so long. So I took the two electrolytics and I put a voltage on them, about 15 volts, for about an hour or two, and I want to see if it's improved the ESR. So here I've got the ESR meter, and that one is about 3.25 ohms, so it has gone down. So let's give this one a try. Oh, that one's gone down to below 1 ohm. That's good. 0.75. So let's see if it does it again. Whoops. So that's the second time it said 3, and now it's gone down to 0.25. So the ESR has gone down considerably. Let's just give that other one a try. That's sticking at 3.2. Let's give it a chance to recover, I guess. Now it's shorting out. Stick them right there. Yeah, it's back to 3.2. So it has improved. So all I wanted to know was if I could use those in my next project. So I think I will.